Section 3, we will discuss graphing the intercepts of a linear equation. Here the graph of y equals 4x minus 8 is shown. Notice that this graph crosses the y-axis at the point 0, negative 8. This point is called the y-intercept because that is where our equation intercepts the y-axis. Likewise, the graph crosses the x-axis at 2, 0. Similarly, this point is called the x-intercept because this is where our equation intercepts the x-axis. So we say the intercepts of the equation are 2, 0 and 0, negative 8. So if a graph crosses the x-axis at 2, 0 and the y-axis at 0, negative 8, then we would say 2, 0 is the x-intercept and 0, negative 8 is the y-intercept. You might notice that for the x-intercept, the value of y is 0, and this will always be true. And for the y-intercept, the x value is 0, and that will always be true. And sometimes in mathematics, the 0 isn't always shown. Sometimes we might say the x-intercept equals 2, or the y-intercept equals negative 8. And in saying x-intercept and y-intercept, the zeros and the appropriate location would be understood. Here's the process for finding x and y-intercepts. To find the x-intercept, let y equal 0 and solve for x. To find the y-intercept, let x equal 0 and solve for y. It is possible at any time for 0, 0 to be a point on the graph. And in this case, we would say 0, 0 is an x-intercept and a y-intercept because this is the only point that actually lies on both axes. This is the origin where both axes intersect. Let's start by graphing the linear equation by finding and plotting its intercepts. So we are given the equation negative x plus 5y equals 10. I'm going to start by making the xy chart that we used in the last section. But now the coordinates we're going to use are relegated to 0 for x and 0 for y, because remember, this will help us find the y-intercept and the x-intercept, which is exactly what the instructions have asked us to do. So we start by replacing the x value with 0. Now you may notice we have a negative sign in front of 0. That's completely irrelevant. Anytime we are adding or subtracting 0, we just cross it out anyway. Please do not add 0 to each side or subtract 0 from each side. It is unnecessary. So we cross out the 0 that was being added, and we're left with 5y equals 10. We then divide both sides by 5, which gives y equals 2. To find the x-intercept, we would plug a 0 in for y. So in doing so, let's solve for x. 5 times 0 is 0. And if I'm adding or subtracting a 0, we can just cross it out. That leaves us with negative x equals 10. We divide both sides by negative 1. The negatives cancel on the left-hand side, leaving x equals negative 10. Let's go to the next slide and graph these two intercepts. So we had 0, 2, and negative 10, 0. To graph the y-intercept, 0, 2, we start at the origin. We don't move any left or right. We move 2 units upward. To graph the x-intercept, we start at the origin. We move 10 units to the left. We don't move any up or down. And that makes sense. The x-intercept should lie on the x-axis. The y-intercept should lie on the y-axis. If for some reason you have points that don't lie on the x and y-axis, and you're trying to find intercepts, you know you've worked the problem incorrectly. So we draw a line through these 2 points, or as close as you can using your pencil. Know that when you plot these 2 points in my math lab, it will plot perfectly. So you don't have the error that clearly I have on the screen. Here's another example. Let's graph 2x minus 5y equals 10 by finding and plotting its intercepts. So again, we start by drawing our xy table, our xy chart. And again, the only coordinates we can use are 0 for x and 0 for y. We must use 0 for x and 0 for y because these are the only coordinates that will give us intercepts. So we start by replacing x with 0. When we do so, we have 2 times 0, which is 0. Whenever we are adding or subtracting with 0, we cross it out completely. That leaves us with negative 5y equals 10. So we divide both sides by negative 5. On the left side, the negative 5's cancel, and we're left with y equals negative 2. To find the x-intercept, we replace y with 0. Again, 5 times 0 is 0. When we are adding or subtracting with 0, it's unnecessary, so we just cross that term out. That leaves us with 2x equals 10. We divide both sides by 2. The 2's cancel on the left-hand side. We have x equals 5. Let's use these two intercepts to graph the equation on the next slide. So we had 0, negative 2, and 5, 0. First, we go to the origin. If we want to plot 0, negative 2, we move 0 in the left and right directions. We move down 2 units and place a point. For the point 5, 0, we start again at the origin, move 5 units to the right, 0 units up or down. Once we have 2 points, we draw a line through those 2 points. Again, my artistic abilities are horrible, so that's why we use the computer program, because it will plot these lines very nicely, very neatly. And let's try one more example where the terms are rearranged somewhat so you can see what types of problems you might have in the homework. Again, we are finding the graph of the equation by plotting its intercepts. So we make the same chart we've seen in the previous examples. We use 0 for the next coordinate, 0 for the y coordinate, and we solve. So we start by replacing x with 0. Four times 0 is 0. Just like we have before, when we add and subtract with 0, we cross it out completely. And we're left with y equals 8. To find the next intercept, we plug in 0 for y. That gives us 0 equals 4x plus 8. And now we must solve for x. So we subtract 8 from each side because opposite 8's cancel. On the left-hand side, 0 minus 8 is negative 8. On the right-hand side, we're left with 4x. We then divide both sides by 4. The 4's cancel on the right-hand side. And we're left with x equals negative 2. Now that we have two intercepts, let's go to the next slide and plot those intercepts. So we had 0, 8, and negative 2, 0. Remember, 0, 8, the x-coordinate is 0, so 8 is the y-intercept. So we can just go along the y-axis, find 8, plot the point. For negative 2, 0, the y value is 0, so this is the x-intercept. We go along the horizontal axis until we find negative 2 and plot a point. If you don't like that method, you can always use the method where you start at the origin, count so many units, left, right, up, down, and place your point. Now that we have both points plotted, we draw a line that goes through each of those points with arrows at the end. And this is the line that represents the equation y equals 4x plus 8. Here it's important to note that vertical lines and horizontal lines each only contain one intercept. A vertical line always has the graph x equals c, or x equals a number. And a vertical line only has one intercept because it will only touch the x-axis one time. Likewise, horizontal lines have the graph y equals a number. Horizontal lines will only have one intercept. Because they are horizontal lines, they will touch the vertical axis one time. So they will have only a y-intercept. So let's graph the linear equation by finding and plotting its intercepts. Now, just like we said before on the last slide, if we have only x equals a number or y equals a number, there will only be one intercept. So we will have to use the information and the fact that each vertical line or horizontal line corresponds to one of these special types of equations, plot our one intercept, and then know what type of line we have. So we start by solving for y in this case. We add 2 to each side. The opposite 2's cancel, and we're left with y equals 2. Going back to the last slide, remember when y equals a number, this is a horizontal line. And horizontal lines only have one type of intercept. That is a y-intercept. We have y-intercepts anytime the x value equals 0. So we plot our one y-intercept, 0, 2. And since we have a horizontal line, we can place any point to the left or to the right of the original point. I'll just put a point over here, 5 units to the right. We can place any point as long as that point will give us a horizontal line when we connect the dots. Another method you can use while you are learning these facts and how to use them is by using the XY table, just like we did in the last section. But you have to remember that y is relegated, the y coordinates are relegated to 2. We cannot use any other coordinate value for y. And since x does not show up in the equation whatsoever, we can use whatever values we want to for x. Here's a similar equation where we also have just one variable. So whenever one variable is present, let's isolate that variable. We subtract 8 from each side. The opposite 8's cancel. We're left with x equals -8. Using the information we saw 2 slides ago, anytime x equals a number, this is a vertical line. And vertical lines only have one type of intercept. That is the x-intercept. The x-intercept would be -8, 0. So we go and we plot that point. We go to the left. We find -8, 0. We plot a point. And because we know that x equals -8 is a vertical line, we find a point that is directly above -8, 0 or directly below -8, 0. It doesn't matter, because above or below, those 2 points will connect to form a vertical line. This is very useful information, at least the information you just saw about the vertical lines and horizontal lines, and it will help you out later on in this module as well as later modules. So make sure that you write those things in your notes and try to commit that to memory.